In this video, we'll take a look at the Zenith GG601 Universal Portable Radio. Zenith was a renowned electronics manufacturer, most known for their radios and televisions. Founded in 1918, they started with amateur radio equipment and expanded into car radio, consumer audio, and eventually television and computers. It still exists as an R&D division of the Korean LG Electronics. The model 6G601 was called the Universal Portable. Sometimes called three-way, this term was used for radios that could operate on 110 volts AC or DC or on battery power. It was a type introduced by most major manufacturers of the 1940s and used the recently developed low battery drain 1.5 volt Lochtel tubes. Introduced in 1940, this was Zenith's most expensive model of portable AM radio of the time. The original retail price was $34.95 and would be equivalent to over $2,000 today. It utilized the newly patented wave magnet antenna, which became a feature of the subsequent transoceanic models of shortwave radios. The 6G601 was available in 5 finishes: a blue-gray cotton airplane fabric, brown and ivory cotton airplane fabric, genuine top-grain cowhide, waterproof simulated brown alligator, and brown cotton airplane fabric. This unit is the 6G601 MOH model in brown and ivory cotton fabric, which for some reason they called airplane fabric. The Zenith AM radios matching the transoceanic shortwave models were known as companion models, and this radio matched the 7G605 transoceanic, but was actually introduced before that radio was on the market. The simulated brown alligator model matched the 7G605 transoceanic. I also own this Zenith model H500 transoceanic and have made a YouTube video about it. The 6G601 was manufactured from 1940 to 1942 with 225,350 units believed to have been produced. A factor in ending production was that Zenith was shifting manufacturing to wartime production of radios for the military in the spring of 1942. Considered to be one of the best pre-war AM portables built, the industrial design was believed to have been by Robert Budlong, the designer of most of the Zenith transoceanic radios. The 6G601 is an AC, DC, or battery-operated portable 6-tube AM broadcast band receiver. The frequency tuning range is 540 to 620 kHz. Power consumption on 117 volts AC is 20 watts, and audio output power is 360 milliwatts. The unit is self-contained and can be carried by the handle on top like a small piece of luggage. The front panel opens with latches and hinges and can be removed during operation. The 5¼ permanent magnet speaker behind a grill with a yacht pattern gave the receiver its distinctive look. The front panel controls are simple: one knob for power volume and one for tuning, which is indicated on a large dial. A red flag on the dial indicates that the power is on to help avoid inadvertently leaving on at low volume and draining the battery. On the back, a hinged panel opens with 2 latches. A line cord is provided for AC power and a cutout for the cord in the back. A large battery can be stored in the lower compartment and connected by a cable. The most notable feature is the wave magnet antenna, which became a feature of the transoceanic shortwave radios. It can be kept inside the case or removed and extended with a cable. Two suction cups allowed it to be attached to the window of a car, train, or ship. The use of the higher antenna placed away from the metal gave the radio better sensitivity than those with a smaller fixed built-in antenna. You could also connect an external antenna and ground, if desired, to the wave magnet using terminal screws. A 3-position switch on the back of the chassis is adjusted for the best reception, depending on the position of the antenna and the listening location. You remove the chassis from the case by removing 2 screws on either side, unplugging the cable of the speaker, and pulling it out. Note the asbestos pad under the chassis. As some resistors under the chassis get quite warm during operation, this prevented avoiding overheating of the wooden case that it sits on. Asbestos is a carcinogen, but should generally be safe if it's not flaking loose material and you leave it alone. I wore a mask when I dusted out the chassis using a brush. The major components above the chassis are the 6 tubes, tuning capacitor, IF transformers, and filter caps. The matching transformer is mounted on the loudspeaker. It's a pretty conventional 6-tube superhet radio design. The tube lineup is a 1 LN5 RF amplifier, 1 LA6 converter, 1 LN5 IF amplifier, 1 LH4 detector and first audio amplifier, and 3 Q5G power amplifier. A 117Z6G is used as the rectifier in the power supply. It uses a 455 kHz IF frequency. 4 of the 6 tubes are of the Lochtel type, which features a base that snaps into place with a locking mechanism and was often used in car radios of the era. There are also low current 1.5 volt filaments. The 3Q5G on the right is an octal tube with a 3 volt filament. The rectifier tube on the left is also octal and has a 117 volt filament. It's only used when running from AC power. Underneath the chassis you can see that the wiring is point-to-point using the tube sockets and terminal strips. There was a significant amount of labor involved in assembling and testing the radio, which was done at a large assembly plant in Chicago. The battery was a Zenith model Z985. It supplied both 9 volts for the filament A supply and 90 volts for the high voltage B supply. The 5 tubes when in series added up to the 9 volts for the filaments. To use the battery, you would connect it via the cable and then insert the AC plug into openings in the rear of the chassis, which activated a switch to change the power supply wiring. With an extension cable, the radio could also operate from the larger Zenith Z884 1000-hour farm battery. Tube radios that operated on these batteries were often called farm radios, as they were used on farms that didn't yet have electrical power in the 1930s and 40s. These Zenith batteries became virtually unobtainable by the 1960s, and most users presumably then just ran them on AC power. Let's power it on. The Lochtel tubes warm up almost immediately, but the rectifier takes a few seconds from a cold start.
Sox 9-2 in the first of a day-night doubleheader. 2 home runs for DJ LeMahieu. Boston has now lost 6 in a row. The Cubs just beat the Brewers 4-1 in Cole Hamels' return. He throws 5 scoreless. Albert Almora Jr. with a home run. He drives in 2.
Here in Ottawa, Canada, there are 3 local AM radio stations, none of which play music. Local stations could be picked up with the wave magnet antenna stowed inside the case. To pick up more distant stations, or if you were in a more remote area, you could remove and extend the antenna and possibly attach it to something higher like a glass window. This radio was given to me by my daughter Jen for my birthday in 2019. When received, it looked complete, although a bit dirty, with all tubes, the wave magnet, and battery cables. One suction cup was missing from the wave magnet. I noted that it had serial number T743205, and it still had a label inside to write the name of the owner. I cleaned the case with a damp sponge and then with some Murphy's oil soap, which took off some of the dirt. The line cord was extremely brittle and missing insulation in some places, so I immediately replaced it using a new 2-wire extension cord that is similar to the original. A circuit diagram and minimal information on voltages and alignment can be found in the Zenith Service Manuals, Volume 2, page 189, which I have on CD-ROM. The same information is also available in Ryder's Troubleshooting Manual, Volume 13 for 1942 in the Zenith section. Carefully powering it up with a Variac, it seemed to be dead with no audio from the speaker. The 2 octal tubes lit up. The other Lochtel tubes typically don't show a visible filament glow. At least one of the wax paper caps was leaky and causing the radio not to work. It also looked like at least one cap had been replaced because it was a different brand and it was not soldered in place well, just tack soldered. I replaced all of the wax paper caps with modern equivalents. At that point, I started to get some audio from the speaker, but no stations received. Testing indicated that the electrolytic filter caps were mostly bad and needed to be replaced. There are 2 cap cases, one of which internally has 2 capacitors and one with 3. I removed the old filter caps by unsoldering the terminals and drilling out the rivets. New and smaller caps were installed under the chassis using terminal strips to hold them in place. I removed the cardboard tubes from the original caps and inserted them over the new caps using some foam to keep them in place. It now looks original but can be removed for access. Checking the resistor values indicated that all were within acceptable limits of the correct values. Powering the unit up, it was now receiving stations and working pretty much as expected. Some intermittent audio was fixed by cleaning the tube pins using some fine steel wool and contact cleaner. I also cleaned the volume control with contact cleaner. The switch on the volume control was not working and was permanently in the on position. It's an unusual control with a double pole single throw switch which is unobtainable anymore, so I decided to simply live with it having the radio always switched on. Note that the unit doesn't have a transformer, so the common negative point is not at ground. It's connected to one side of the AC line. This means that you can't connect grounded test equipment like an oscilloscope to this point, or it may short out the power. It's highly recommended to use an isolation transformer, which I did. Fortunately, the chassis is not connected to this ground. The chassis is connected to the AC line via a capacitor, so there is a danger of shock if this capacitor becomes leaky. The two screws on either side of the case are connected to the chassis, for example. The dial cord was slipping as the original had been replaced with some cotton string. I replaced it with some cloth fishing line, which is close to the original cord material. I then went through the alignment procedure, which is outlined in the service data. It consists of setting a signal generator to the 455 kHz IF frequency and adjusting the 4 trimmers of the 2 IF transformers for maximum output. Then you adjust the wave trap for minimum output from 455 kHz. A wave trap was a feature of early radios that was intended to filter out possible signals from maritime stations that could be at or near the IF frequency and be picked up on the radio. You could adjust it to block a different frequency if there was interference from a specific station. You then adjust the tuning capacitor trimmer so that the dial indication is correct at 1400 kHz and peak the RF trimmer for maximum output. After completing the alignment, I put the radio back in the case. Strangely, it didn't work. I took it out of the case and now it worked again. After some head scratching, the explanation came to me. One of the mounting screws, which goes into the chassis, was touching and shorting a cap inside. It simply needed to be pushed out of the way. The radio as received had a second set of battery wires connected. A previous owner had apparently added wires to allow using separate, high voltage but still available batteries in place of the hard to obtain Zenith battery. I removed them and also replaced the battery wires as they were crumbling. There are some options for the battery which is no longer obtainable. You can use 6 D cells for the 9-volt supply and 10 9-volt batteries to generate the 90-volt supply. If desired, you could put this in a cardboard or wooden box of suitable size. This will work but won't last too long with 9-volt batteries. There are also replacement batteries like this one that I purchased for my H500 transoceanic. This unit takes 10 D cells and uses circuitry to generate the 9 and 90-volt supplies and works for many hours of use. Unfortunately, the radio is not working with this battery. It seems my battery unit only puts out about 7.8 volts for the 9-volt output. Unfortunately, I don't have a schematic or other technical information on the battery and its circuit, and they're no longer being made. Most of my videos are about Heathkit products, but there is an interesting connection here with Zenith. From 1979 to 1989, Zenith was the parent company of Heathkit, which they acquired primarily to get into the growing personal computer market. Some people attribute the shift of focus and resources to computers as a factor in the demise of Heath's kit business. It's quite impressive that a radio almost 80 years old is still working and still compatible with the radio stations in operation today. The Zenith Universal is quite a collectible and sought-after radio with its attractive industrial design and good receiving performance, and it's historically important because it helped lead the development of the famous transoceanic series of shortwave radios.